G'day everyone. Day 10, Poisson process emulator, aka a Geiger counter prop. So generating signals that sound like a real Geiger counter is actually, a little bit challenging. You can't just take a white noise source like a noise diode and just, amplify it. But you can do something pretty similar. In order to generate the Poisson distributed statistics of what a Geiger counter sounds like, you can take a white noise source and you can threshold it and then run it into a monostable that produces the click sound that the discharge of the Geiger mode of a Geiger counter tube would generate. So I came up with a pretty straightforward circuit. It's only a couple of transistors, super easy to build, that can make something that is a pretty convincing Geiger counter. You can hook up to that threshold voltage a number of different things. So it could be as simple as a pot that you just simply serendipitously, or the actor, if you're using this say in a performance piece, can manipulate covertly, or you could hook it up to a number of other things like potentially a light sensor or a magnetic sensor, any kind of way that perhaps when you approach an object that has been suitably prepared or is just simply ferromagnetic, the click rate and the random click rate of the device will increase and it sound like that particular object is radioactive. So this is just a fun little circuit. It's silly, but it's the kind of thing that you could totally make for a kid as a toy. So here's the circuit. The noise source is super straightforward. We've got a reverse biased base emitter junction, which is an inherently noisy avalanche kind of source. I use 2N3904 transistors for everything here, so it can be just absolute garbage variety transistors and it will work. The power supply is 9 volts, so it will run off a 9 volt battery. In fact, you can build a nice little 9 volt battery topper kind of thing that looks a little bit like maybe an old cutie pie, because you know how ridiculous in the movies is someone holding an ion chamber, like a cutie pie ion chamber, and the thing is making clicks on the sound. That's been dubbed over it, which is clearly not what ion chambers do. They deflect a needle and they're a proportional device, but I digress. It's just something that bugs me about old movies. You see the classic cutie pie style ion chamber and it's making clicks. But anyway, so noise source, amplifier. This is a garbage common emitter amplifier, produces audio noise. You can actually hook your audio amplifier up here and you get a nice hiss. If you want an RF source, you might want to make this a little faster, maybe with a cascode. But the noise generated here is actually broadband and white. So this is a really good, an okay white noise source, certainly fine for our purposes. For thresholding, instead of using an op amp or a comparator or something, I just simply cheated and used the monostable's input trigger threshold as our thresholding, and I bias it with a voltage source. So I've got a voltage divider here, which is just a pot. Nothing really happens until you get up to about 0.3 volts, and then the noise here, which is a couple hundred millivolts peak to peak. Well, I mean RMS. It's not really peak to peak, is it? If it's a white noise source, but we'll start to trigger the monostable by forward biasing this transistor, and it turns on. The time constant of this capacitor and resistor determine how long it stays on. It's a regenerative circuit, so it slams on and then slams off and produces a pretty rectangular looking pulse. The edges aren't perfect, but the time constant here is about 80 microseconds, so that's a fairly high frequency click, so it can actually count at pretty high rates. Whether or not that's necessary for something that's a prop, it could sound more like a scintillating counter potentially, but that's what I picked. Feel free to change other values or add some audio filtering before you run it into an audio output device. I'm using my bench, my little mini Archer amplifier here for the practical circuit, but a piezo sounding element actually works absolutely fine, and at 9 volts is plenty loud for a toy. But if you want a nice loud click, you might want to add a little bit of audio amplification. So anyway, we produce this voltage at 1 volt. It's pretty much starting to sound no longer Poisson anymore, and the white noise is really driving around this the monostable and tending to overdrive it. This series resistor is probably not really necessary, and this diode just makes sure that at least only one direction of the noise is actually going into this transistor. Makes it less likely to pull the monostable around. And here's some basic sensor ideas. You might want to use a retroreflective sensor where you've got an LED or a photodiode. It's a photodiode, you can use an infrared LED, and the emission so this is basically 2 tubes. You just shove a photodiode on one side and an LED in the other so that no light can go this way. There's a baffle basically, and when you approach an object here, this backscattered radiation will be detected by the photodiode. Then it's a simple matter of probably a single transistor transimpedance amplifier, or with an LDR it might actually be sufficient to just have some resistors and use that to generate this 0.3 to 1 volt kind of bias. You can use a Hall sensor. You get linear Hall sensors that will do just fine for this application. You might just need a resistive divider on the output of those, or you could do something more elaborate with a search coil. So you could either put an RF source, or you could make like an induction or heterodyne metal detector. I mean, there's a bunch of different things you could do, but the easiest thing is just simply to have a pot serendipitously located on your thing, or maybe a squeeze kind of capacitive sensor. I'll leave that up to the reader and implementer of these circuits, but the core idea is noise source, thresholding, monostable sound output, and it sounds pretty much like a Geiger counter. So here's a practical circuit. It's just made on some solderless breadboards out of the sweepings that I had this old ISA card box that I used to take to university. It's chock full of old resistors and capacitors and crap that I used in uni, so I got all the values out of there. It's basically bench sweepings. Alrighty, turn it up a little bit so that you can kind of control the threshold here. So it goes from a little bit above background to kind of like, you should run away now levels. But yeah, I mean, you probably want to set it up such that you get something like maybe a little bit less than where it is now as your background. Maybe that's where the pot's at minimum travel. Or you can have it such that you can actually have it well and truly cut off so it's completely quiet. You might want to use a switched pot to save batteries. The power consumption is less than 10 milliamps. I didn't actually even measure it, but a 9-volt battery will last a long time. It does kind of need a moderately higher voltage for the noise source. You could potentially use a different kind of noise source. Like if you just cascaded a couple of common emitter amplifiers, their inherent noise would probably be quite sufficient for, particularly if you use kind of crappy transistors. Not that the 2N3904 is a particularly low noise transistor, but it's good compared to old transistors. An old a leaky old germanium transistor would probably be a great noise source. But you could use a Zener diode here. Base emitter junctions, they're fine. Anyway, yeah, a little bit of a fun thing here. Maybe as a toy for Christmas for someone, or just for fun to, freak your friends out. Not that I would endorse making something sound like there's a radioactive emergency happening. Not that, so few people really understand that you can have a whole lot of clicks. You can be saturating a Geiger counter completely such that its dead time is, essentially held constantly in it, and that's probably not enough radiation to warrant running away. But certainly if that ever happens to you and the Geiger counter goes quiet when it's near something and it was clicking as you approached it, that's probably a sign that you should stay the hell away from whatever that is. Alrighty, have a good one. Speak to you tomorrow. Well, have something hopefully new and exciting tomorrow. We'll see. Squeezing creativity out of yourself day after day can be... it's actually a therapeutic exercise. I enjoy it. That's one of the reasons why I make these videos. Alrighty, bye.